Good morning. I'm John Seegers, and this session is ArcGIS as a tool for infrastructure documentation and asset management, establishing a GIS for computer network documentation. Most of the background images originate from a production version of this framework and serve to illustrate some of the features and benefits of adopting a hybrid framework system such as this. Managing any multi-building production network is a challenge. Managing and maintaining a geographically dispersed network is even more challenging due to the numerous WAN connections supporting a myriad of building interconnects, which in turn supports numerous internal LAN connections. The task becomes fraught with problems from the start. Common issues are switch and equipment firmware revisions and their compatibility, as well as basic asset locations, both within the buildings and within their respective equipment racks. Add to this amalgamation, new users, administrators, and confusion is certain. Having a basic framework from which to begin eases the burden and can help shorten the process of filling in the blanks concerning equipment and asset location, and allows the organization to focus on creating and capturing the data and information it requires in order to better manage infrastructure and inventory. In this illustration, we see the completed framework rendered in a JavaScript environment. Visually, we see information in the form of attachments on the left and right, while the pop-up window in the center presents basic attribution about a selected vault. This information is readily available in a concise, easy-to-read environment accessed via a standard web browser, and is one benefit of adopting such a framework. In this presentation, we're going to take a high-level look at creating a GIS framework. There are two primary types of network documentation, logical and physical. Most organizations have software which will generate or render a depiction of their network's topology, such as the one displayed in this image from the University of Michigan. And some of these even present lists of equipment which comprise the network. These are logical diagrams and are generally created through an automated discovery process. Often what's lacking from network documentation is adequate spatial or locational information as to where these items are physically located and how they are physically interconnected. A hybrid methodology, which combines the logical diagram and the physical layout, is a better solution for many organizations. The project involves creating a framework or model which can be used to assist in the documentation of the physical network infrastructure for an organization. The target for this project is the University of North Georgia, UNG. Many smaller agencies lack the resources necessary to adequately document their physical networks and infrastructure. Through partnerships with organizations such as ESRI, these types of agencies may gain access to proprietary software and services through low or no-cost arrangements. A hybrid framework allows the organization to blend information and capture both the logical network design and the physical layout as well. This added documentation does not come without a cost, however, because the addition of the physical network component requires more manual documentation efforts. This contrasts with a logical system, which is software-based discovery. It is used in most situations simply because of the ease of implementation. Items not captured via a discovery-based system include any devices which cannot communicate with the discovering or polling software. Examples shown in the image include ladder racks, equipment racks, fiber distribution shelves, patch panels, and cable management devices. It is worth noting that in this image, there is only a single item which can be discovered via a logical topology creation software, and that is the chassis switch highlighted. As the project began, the only network documentation was a logical diagram. There was no organized data on any of the physical devices on any of the campuses. There may have been tidbits of information here and there, but certainly nothing remarkably helpful in locating devices and hardware. Existing staff simply relied on knowledge from the person that had been there the longest. The framework began by establishing a defined digital archive and creating basic feature classes in which to store the required data in a relatively simple GIS, which could be accessed from a desktop computer. In most GIS setups, the transition from defining the archive to creating the database relies on someone with a knowledge of GIS and who possesses relational database experience. This framework circumvents that requirement and provides the basic building blocks so that an entry-level person can understand, digitize, and populate the features and tables which form the core of the framework. Project conception and growth touches on three areas. First, we'll look at the initial model or framework to provide spatial information in map form so that workers may better locate the intermediate distribution frames, IDFs, and main distribution frames, MDFs, sometimes called data closets, and perform audits via a desktop session. Next, we review issues with scope creep, which caused delays and forced us to refocus our efforts back to the core needs of the project, which were establishing and populating the base map and operational data layers. Finally, we eliminate distracting issues by regrouping. Focus was returned to the creation of basic network structures, which would support the features and enhancements necessary for future growth. Digitizing and creating the base maps is time and labor intensive. This process is necessary in order to provide the appropriate context for the mission of the project, which is to orient and guide users to IT-specific assets and their locations. At the same time, though, care must be given in the creation of these feature classes to ensure that the various data types support the attribution needs and maintain the flexibility required for future growth. The area circled in red will be the focal point of the next slide. This initial model, or Framework 1.0, was conceived in order to aid in the documentation of maintenance tasks required to be performed in each of the IDFs and MDFs across the various campuses. For example, on the campus displayed, there are some 47 IDFs and MDFs, each of which houses equipment and must be checked and documented on a monthly basis. The basic information required to address the minimum functional requirements for the framework includes the building footprints, detailed floor plans, attribution to indicate asset locations, as well as a means to navigate around the map documents and to allow for the recording of maintenance details. It is worth mentioning that scope creep can be stealthily subversive within the guise of adding project benefits. In reality, however, creep is anything but beneficial to the project. Often, scope creep is a primary cause for a project's failure. It comes from a variety of sources, both internal and external to the project. The bullet items listed are all items or requests which slowed progress on the 2.0 version of the framework. A fine line exists between capturing the necessary features and attributes while building a framework that allows for future growth. A key point is operability of the system. That is, establishing a system or framework which works as intended, but can also be upgraded to a more advanced framework version without sacrificing either data continuity or its usability. Each organization will encounter different scenarios and obstacles, and having the skills to effectively identify and navigate around these issues is critical to staying on track and ensuring project completion. Having a well laid out project plan with very specific goals, accurate functional specifications, as well as detailed user requirements can go a long way in mitigating scope creep before it has a chance to take root in the project. Once recognized, specific actions must be taken in order to mitigate creep. In this project, we needed to review the project's functional specifications and any specific user requirements, as noted by the bullet points shown, and focus on ensuring that these items have been incorporated and are indeed accounted for within the framework. Out-of-scope requests and enhancements are documented and pushed to the next major framework revision. The 2.0 framework includes features, feature classes, tables, relationships, and attachments, which work together to assist in creating a clear picture of the infrastructure, its organization, and layout. ArcGIS is used to create both the base maps and operational layers, such as conduit routings, fiber and copper cables, rack and vault locations, junction boxes, and so forth. Once the framework's features are digitized, they may be presented as shown as an overlay upon georeferenced architectural drawings or other operational layers. This type of information facilitates planning because accurate georeferencing using an appropriate projection allows calculation of distances so project and cabling estimates may be generated without requiring a site visit. These digital assets are then added to their respective feature classes as attachments for easy reference. ArcGIS and its successor, ArcGIS Pro, are perfectly suited to house and expand the framework by providing the user with robust tools to create and edit both spatial assets and their attributes. The completed 2.0 model is a fully functional framework pre-constructed with the necessary feature classes, relationships, supporting tables, basic queries, and reports to begin documenting and laying out one's physical network design. This framework may be an aid to other organizations in developing their own asset management system through a GIS. Key benefits include centralized data storage, reporting functionality, planning aids, visualization of infrastructure, all easily scalable to incorporate 3D modeling and more. Here we take a look at the framework in practical application. From an ArcGIS desktop session, we show the student health data closet in red hash. We've drilled down into the A rack to display the equipment it houses using an identify tool. On the left is an attachment in the form of a photograph for the A rack showing a typical Aruba chassis switch. We've also expanded the maintenance history for this piece of equipment on the right to show the task recently performed, such as replacing a faulty power supply, updating the firmware, and so forth. For individual pieces of equipment, attachments may be saved as well, such as an image, a copy of the configuration file, the manual, firmware, etc. Here we see the basic system design currently in use at UNG. Access is limited to certain clients via IP address, and remote access, while limited, is available through a VPN connection. Obtaining data and reports from ArcGIS directly is a bit limited because it typically only allows a single table or join tables to be queried. Accessing data from the database backend circumvents this limitation and allows for much more robust query capabilities. The background image here shows a simple query example utilizing the PostgreSQL GUI. Postgres was selected primarily because it is a free and open source software solution. It is supported as an enterprise geodatabase. It does support replication, which allows data to be maintained inside the UNG network and automatically replicated out to an Amazon Web Service. Other database options include Microsoft SQL Server, Oracle, Informix, and DB2. These are all enterprise geodatabases and provide advanced functionality which may not be necessary for every organization. And if this is the case, then the organization might consider utilizing either a personal or file geodatabase. This image is an entity relationship diagram, or ERD, from a PostgreSQL session. This helpful diagram may be generated in more recent versions of PostgreSQL and is useful in that it shows the various feature classes, tables, their fields, and data types. Maintaining a physical network design is difficult, which is why so many organizations opt to have only a logical design. Part of the problem with maintaining the physical design is capturing the appropriate attribution in the correct location. This is where the data dictionary plays a critically important role. This document is key to one's understanding of the feature classes, relationships, attachments, and naming conventions used throughout the information system. The data dictionary expands upon the ERD by describing in detail the various fields, what they store, the data types. It goes on to explain any relationships as well as any attachments. It details any naming conventions in use and provides the user with basic information with which to create and update other metadata. Here's an example of a JavaScript interface, which is used to access the map document via a standard web browser on a desktop or tablet device. With the 2.0 framework and knowledge of basic GIS processes and procedures, most any organization has the capacity to create or improve their existing network infrastructure by incorporating the framework's basic set of features, tables, and attributes as a starting point. Obviously, each organization will need to tailor the framework's components to meet their own specific needs, but the 2.0 framework provides enough resources to get the project off to a very nice start. Here we see details on several ideas for future framework enhancements. Adopting an infrastructure framework such as this will not be easy, but utilizing this framework can save many hours, if not weeks. It will aid in getting your infrastructure documentation project off to a smooth start because you'll have a good starting point from which to begin and the tools necessary to be up and running without having to start from scratch. And thank you.
Great job, John. Perfect timing. Seems like a super practical project. Great work. Does anybody have any questions? Looks like Ryan has, yeah.
Sorry, it took me a second to get reoriented and I lost the question. Let's pull it back up. Does the university have an existing CAD system of this infrastructure that could or should be integrated with your GIS? And the answer is not currently. We do have infrastructure in CAD, but nothing IT specific other than generic fiber lines, nothing in terms of actual infrastructure in buildings.
And if anybody wants to just turn on their mic and ask questions, that's fine too, or just type in the chat like Ryan did. I'll ask a question while people are thinking. And it looks like Ryan has a follow-up there. I was just curious, what how long ago did you conceive of this project, John? Like, how long has this been in the works or on your wish list to do?
For as long as I have been in IT, pretty much at both UNG and in previous employment. I had worked on infrastructure projects in a previous jobs, but nothing tailored specifically to a campus area network. And this is something that's very much needed. So I've been dabbling with this for probably a couple of years at least.
Great. I think it's quite unique. I guess your advisor would know how unique it is, but probably worth sharing with other universities. It looks like Fritz has a question there.
Did you get any, this was from Dr. Kessler, did you get any feedback from end users during the development phase? Or do you plan to solicit input from end users during further development to improve functionality? Absolutely. As an end user, I worked in the networking department for the university. So I collaborated in great depth, and that's where a lot of the scope creep came in, because it was oftentimes people would say, well, let's just add all the wireless access points. And I'm like, okay, that sounds good. And so I went down that rabbit hole. And anyway, so yeah, we had input. Sometimes it was not certainly helpful, but input nonetheless. And management is really keen on the idea, especially in terms of getting, as my advisor, John has helped me figure out how to get more physical plant infrastructure documented through a GIS and not just CAD based.
Great. Okay, well, again, great job, and congratulations on almost being graduated.
Yeah, thank you.
Okay, we will move on to Matt Hansen. So Matt, if you want to go ahead and start sharing your presentation, and you can start whenever you're ready.
Okay, sounds good. Is that working?
Yes, we can hear you and we can see it.
Okay, sounds good. So my presentation is Changing Faces in Pennsylvania's Veteran Service Organizations, and my advisor is Dr. Matthews. So this work was influenced by a current Penn State research project to understand more about the needs of post 9/11 veterans and the Veteran Service Organization landscape in Pennsylvania. and if and how it supports veteran residents. To give you just a quick overview of this presentation, I'll discuss the aims of my capstone project and some background information on veteran service organizations, demographics of veterans and how these are changing, and also some information on veterans living in Pennsylvania. And then I'll provide a summary of the data used in this project and the analytical approach taken, followed by a few of my results and a case study examining one VSO in particular, the American Legion. And finally, based on these results, I'll provide conclusions and future directions for this work. So for a bit of background, service in the US military can be a gateway to a variety of inclusive benefits. And while in the military service, the military itself is responsible for most of the needs of the service member. However, once they leave the service, it is often veteran service organizations or VSOs that have aided veterans in understanding and receiving the benefits that are available to them. VSOs are funded from state or county level funds or from private sources. Congress may grant charters to VSOs through legislation. And the oldest combat VSO is the Veterans of Foreign Wars, the VFW. And along with the VFW, the largest congressionally chartered VSOs are the American Legion, Disabled American Veterans, and these three VSOs, along with Paralyzed Veterans of America, American Veterans, also known as AMVETS, and the Vietnam Veterans of America are often referred to as the Big Six and are considered to have an outsized dominance in US politics through lobbying and their advocacy agendas. Representing veterans with the VA is a significant role of traditional VSOs, and they have accredited veteran service officers who help veterans write and submit benefit claims to the VA. VSOs also serve an important social function after separation from the military. Previous research has demonstrated that veterans who are physically engaged and identify with VSOs experience reduced social isolation, greater perception of benefit finding from military service, and both of which are related to lower PTSD symptoms. So shifting over to the veteran demographics, there are approximately 18 million veterans in the United States, representing about 7% of the adult population. The percentage in overall population of veterans has declined steadily since the Vietnam era, and this trend is expected to continue. The military is also becoming increasingly more diverse. Newer generations of service members differ from their older counterparts in other ways too. Younger veterans are more likely to be married and have children while serving. They are also more educated and more likely than any previous era to have service-connected disabilities. The post 9/11 era represents the longest the US has been at war, and therefore will be the largest proportion of veterans spanning the longest period of time. Due to this large span of time, it is highly likely that veterans at either end of this 20-year span may look very different, and their needs may be very different both now and over the course of their lives. Post 9/11 veterans are increasingly seeking different and less traditional options for post-service communities and their support networks. Some younger veterans.
It's something about my benefits.
Sorry, what was that?
I'm not sure, but I just muted other people.
Some younger veterans view the traditional VSOs like the American Legion and VFW as older fraternities, or maybe just a bar, and they desire more active lifestyle options and community-facing organizations. Traditional VSOs may find it increasingly difficult to recruit and retain younger members, and in turn may not evolve in tandem with the changing veteran demographics. In some communities, there may be a distinct misalignment between the services offered by a VSO and the local veteran population. And traditional VSOs, especially the Big Six, with their outsized political voice, may be driven by a minority of the veteran population. And Pennsylvania is fourth in the nation for the total population of veterans, with 800,000 veterans. despite not having any active duty military installations within the state. Veterans in the Commonwealth represent about 8% of the adult population, higher than the national average. 7% of Pennsylvania veterans are women, which is lower than the national average, and 55% of Pennsylvania veterans are 65 or older. So in short, Pennsylvania veterans are more numerous, male and older. As with the national population of veterans, the number of Pennsylvania veterans is declining. By the year 2045, the population of veterans in the state is expected to drop by more than half. So there were two main goals for this project, as well as a few sub-aims for each goal. The first goal was to examine the current landscape of VSOs in Pennsylvania. And to do this, I had to develop a geocoded data set. The second goal was to identify areas that are over or underserved by VSOs based on proximity to the VSOs and veteran utilization demographics. In order to realize this goal, one sub-aim included identification of where the veterans in Pennsylvania are located and their co-location in relation to VSOs. As there were no public data on veteran membership tied to specific VSO locations, the second sub-aim of this goal was to conduct a case study of Pennsylvania's veterans based on service era and their proximity to examine the potential for utilization within one VSO, the American Legion. Developing the data set for this project was a large component, and I want to provide a high-level overview of the process, limitations, and some of the lessons learned. So the U.S. veterans are a very well-reported population. The U.S. Census Bureau's American Community Survey contains over 300 veteran variables. In addition, the Census Bureau provides a number of data tables and reports on veterans. Both the tidy census package in R and Esri's Living Atlas were excellent tools to incorporate the census data into my project. Building a data set of Pennsylvania's VSOs was much more complex. To identify VSOs, I relied on publicly available data from the IRS. Because except for just a few exceptions, nonprofit organizations are required to file a 990 tax form with the IRS, which is then made public by the IRS. The exact filing requirements depend on the characteristics of the organization, but generally more assets and more income require a more detailed version of the form, and we'll have more historical information available. And it's only relatively recently that a large percent of the 990 records have become more available, and recent changes now require all organizations to file electronically, which will hopefully help all of this effort in the future. There are a number of both proprietary and open tools available that attempt to ingest the IRS's 990 data sets and make them more accessible for a variety of different uses. The one chosen for this project was from the National Center for Charitable Statistics, the NCCS, which is affiliated with the Urban Institute. And I chose it because it's freely available and it's also designed and documented for use by researchers. So keeping in mind that these 990 data sets encompass the entire US nonprofit sector, my first step was to identify just the veteran organizations. The National Taxonomy of Exempt Entities, NTEE codes, which are included by the NCCS, are intended to classify the different organizations by their purpose. And the code of W30 represents military and veteran organizations. And the NCSS provides two primary data sets to work with. The first one is the business master file, which is intended to be a routinely updated data set of all US nonprofits. And secondly, is there what they call the core files. The business master file includes more organizations but far less detail, whereas the core files provide a lot more detail, but for a much smaller subset of organizations. And it's generally those who have filed a more detailed 990 form. The latest release of the business master data contained nearly 2 million organizations, but only 33 variables for those organizations, while the core files contains 367 variables. The business master dataset was used for this project as it provided a much more complete picture of VSOs, but for organizations that are also listed in the core files, they can be linked by their employer identification number, the EIN. So the NCCS data identified about 40,000 veteran-related nonprofits in the country. And by filtering this just to Pennsylvania organizations, there are over 2,000 of them. To capture just the big 6 VSOs, I developed some regular expression matching rules against the variables containing the organization names, and I grouped them by type. The challenge here was avoiding duplicates by separating the various sub-organizations affiliated with a lot of traditional VSOs, such as the bars or auxiliary organizations, which are distinct from a tax perspective. This step took some additional time and effort to account for all the special cases and quite a few misspellings in the tax data. Since this was done by me within code, within R, it's all very repeatable, and it would be feasible to apply this over a much larger data set, but some additional automation could also assist here. Overall, there are nearly 1,000 Big 6 VSOs in Pennsylvania, which is roughly half of the total data set, combined with the auxiliary, club, and home type organizations, which are these commonly affiliated sub-organizations that are often affiliated with traditional Big 6 posts. They account for roughly 3/4 of the total VSOs in the state. A benefit of compiling this all from tax data is that there are other variables like assets and income that can also be examined from this. Big 6 VSOs represent about 2/3 of the total assets in Pennsylvania VSO data in the data set, and combining them with the home, club, and auxiliary type organizations, it represents about 80% of the total assets in VSOs in the state. However, this is not necessarily a measure of their impact or the number of veterans that they serve, but it does provide an indication of a very sizable footprint in the state. The last step was to geocode this data set. So I used Esri's geocoding API, as well as an API from the FCC to append any missing county level FIPS codes, as well as validating what was included from the NCCS. So here's a screenshot of the final results of the Big 6 data set that I developed. And this is just a screenshot, but by the type of the VSO for all Big 6 organizations. But the IRS variables are also included as attributes within each organization in the interactive version of this. To export my data out of R, I used a GeoJSON, which was a nice portable format, which can be used in a number of other GIS tools or different web APIs. The largest Big 6 VSO presence in the state is the American Legion, with over 500 posts. Therefore, to examine my other project aims, I decided to focus on just this VSO for now, due to their large presence in the state. American Veterans Organization has advertised itself as being one of the most inclusive VSOs, with their eligibility open to any service member that has obtained an honorable discharge. And that compared with the American Legion, which requires service during specific war eras. In 2019, the Legion Act was signed, which declared that the US has officially been in a state of war since December 7th, 1941, which had the effect of expanding eligibility to approximately 6 million additional veterans. This represents a very significant change in access. It is possibly an example of how these organizations will continue to evolve and serve a changing population of veterans. And now I want to jump into kind of a more detailed case study that I did for the American Legion. So there are 6 maps on this slide representing the number of veterans in each county and their ratio to the American Legion posts in each county. The first slide shows total veterans by post. The other 5 maps show veterans by different age groups per post. The colors represent the ratio of veterans to American Legion posts within the county. And you can see that the darker colors indicate areas where there are a high number of veterans per post, while the lightest colors indicate lower ratios of veterans per post. The gray dots within the counties represent the estimated number of veterans per county, although the scaling is different for each age group. So the scaling is kind of visually equal to each age group. As you can see from these maps, the veteran populations are fairly consistent by age group, with some variations in a couple of regions. There are several counties with a significant population of veterans, but few or no legions. And a couple of the rural counties in particular have no legion posts. As you can see in the total map, as well as across the age ranges, Pittsburgh and Allegheny County have one of the largest populations of veterans in all age groups, but it also has a relatively high number of American Legion posts. And I wanted to zoom in then on Allegheny County in the Pittsburgh area. As you can see, there are over 73,000 veterans living in the county, and based on the VSO data set, it has 154 total veteran organizations, with almost 30% of these organizations being American Legion posts, 42 of them. An interesting note is that according to my original VSO data set, Allegheny County was 6th in the country for the overall total number of veteran organizations. But in terms of population, it's 36th in the country. I think this is a fairly unique area of the country for veterans, and there are a lot more areas to explore here. So far, I've looked at county level numbers and census tracts in Allegheny County, but of course, people aren't really bounded by either of those areas. So to get another aspect of how accessible these locations are, I also examined the driving distance to American Legion posts using ArcGIS Online. This map is an example of the 10, 20, and 30-minute driving distances from American Legion posts. The interactive version of this includes all the different ACS variables describing where where veterans from different service areas are within the driving distance from each post. In this reported that there are over 500,000 veterans living within a 10-minute driving distance to an American Legion in Pennsylvania, which is about 60% of the total veteran population in the state. And nearly 50,000 of those are post 9/11 veterans. Similarly, veteran communities aren't necessarily bounded by state borders. So this would be interesting to analyze at a larger regional or national level too. I think what interested me most about this project was the idea of these historical organizations existing as important physical fixtures in a lot of communities, especially the more rural areas without many other community resources or physical gathering places. Although the veteran population is declining overall, there are still many younger veterans living in all parts of Pennsylvania. This space will be interesting to follow both in Pennsylvania and around the country in coming years as the veteran populations continue to shrink and change. Traditional VSOs still have a very large physical presence in the communities and play an important role in supporting veterans. But supporting younger groups of veterans may require some adaptations on their part. Getting younger veterans to join and stay involved in projects and services that are geared toward them will be very important for VSOs, especially in particular areas like Allegheny County. And some future directions for this work, while I was able to examine all of my project aims, there are still many next steps that can be that could be furthered in this work, including the following. I think I would like to include and classify all congressionally chartered and VA recognized VSOs beyond just the big six. Also expand this to include all US states and territories. An in-depth analysis of other changing factors in the military, like gender, race, education, disability ratings, and income would also be very interesting. I'd also, another opportunity I think would be to create an improved dashboard for data viewing options, maybe store your web maps for exploration by other researchers, advocates, or policymakers. This is a changing area, and so automating the updates of this data set for new census data, future tax years, and to visualize these changes over time would also be very useful. There are 6 state-run VA homes and 56 medical locations that I've already geocoded to include with this, but other locations of things like military installations and other significant veteran resources would also be important to look at. There are also some influential non-chartered and non-VA recognized VSOs, these kind of non-traditional VSOs that would be very important to include and look at as well. At this point, I'm open to any questions, and thank you.
Thank you, Matt. We're going went a little long, so I think we'll, let's see if we can get one quick question. Looks like Dan has a question, so maybe try to do that one quickly, and then maybe you can put your, while your email's there, maybe also put your email in the chat, and maybe some folks can follow up with some more questions after. But you go ahead and answer Dan's.
The question is, while discussing demographics, you share that Pennsylvania's veterans population will drop by half. What factors led to that age moving trends, and how could your study impact VSO membership or location in the future? In your future directions slide, you did cover this. The shrinking number of veterans, I think, is something that's been pretty well reported. If you look at the Census Bureau's reports on veterans, there's a lot of shifting resources here in terms of kind of the declining veteran population, but also, as I mentioned, the needs are changing too. A lot of things like disability and some of the other kind of Gulf War specific concerns. I think the VSO membership would be something that I would have really liked to have to actually study the membership in particular VSOs, but unfortunately that wasn't available. I think this data set could be maybe used as a tool to maybe try to survey and gather some of the membership data. But yeah, that's a good question.
Okay, great. So let's move on. And like I said, Matt, if you're willing to put your email address in the chat, then I have a feeling you might have a couple other questions come your way. But let's keep moving along. So Alan Zolar, if you're ready, Alan, you can go ahead and start sharing and start whenever you're ready.
Sure thing. Just a quick comms check here. Can you hear me?
Yes, we can hear you.
Excellent. Okay. All right. Does everyone have a visual?
You do?
All right, great. All right, so good morning, everyone. I'm Alan Zoller, and I'll be briefing you today on scud hunting with spatial analysis. This will be our agenda as we push through. And with that being said, let's jump into this. So first off, why does this matter? Why does spatial analysis for scud hunting matter? There's never been a more present, more current example of this, or a need for this, than what's going on today, unfortunately, with the Russian-Ukrainian war. And really the Russians following their preference, this historical preference for using indirect fires, be it artillery, rockets, missile attacks. A lot of it's being shown here, and really specifically leaning in towards those missile strikes, having spatial analysis done ahead of time to try to get ahead of these launches that are pushing out, firing upon population centers or troops in general, causing gratuitous death and destruction. Really just trying to get ahead of that, getting that left of that launch, and either getting strikes on that location ahead of time to prevent all of that altogether is where this project really goes. And so moving into this and trying to explain a little bit more of those objectives there. The problem that we're seeing is current early missile warning technology focuses on post-launch detection and warning for their ballistic missile threats, which is resulting in significantly decreased reaction time. So the question then is, how can spatial analysis assist with early missile warning architecture and aid in predicting launch locations? So what this visual is showing is how we currently do this. We're observing an AO, an area of operations. A launch happens, and then we push out the signal, the warning. So getting left of launch, getting ahead of it, the objective is to use spatial analysis to predict transporter erector launchers, TELs, launch locations using historic example of Scud hunting during the Gulf War for the development of a new proof of concept prediction tool. And the desired end state is an effective tool that models a specific TEL's employment, identifying ideal launch locations for improved warning via that refined surveillance engagement. So what this visual is depicting is that we have our area of operations. We've identified an ideal launch position or emplacement position for a TEL. We see that activity, we start pushing the warning, perhaps get a strike in ahead of time to prevent the launch altogether, depending on the circumstances, of course. So a little bit of background moving into Scud hunting in the Gulf War in general. Efforts during the Gulf War were air patrols and strikes. So pushing out those aircraft, having them survey the area, hopefully identifying Scuds before they launch, conducting a strike to remove it from the battlefield. And then they also had the Defense Support Program, DSP, which was the Overhead Persistent Infrared satellite constellation used to detect that heat over or intensity over time launches that were taking place and be able to push that warning out as soon as the launch happens and it's able to detect it. Some efforts after the Gulf War, since there was a bit of a deficit there that was identified, was Project Stalker. And Project Stalker was targeting the shoot and scoop methodology of the Iraqi TELs that were being used for a bunch of those Scuds. So in this case, though, the shot would take place and they were focusing on the scoop portion. So they would get the data, receive the data on the shot that was taken, and then they would plug it into a modeler using GIS to try to predict where it's going to go next. So very reactive rather than proactive. And then Tiger was the follow-on command and control suite that Project Stalker got rolled into, and eventually Tiger faded out of existence from development, unfortunately. So there isn't really any remnants of it today. But what there is remnants of is the upgraded space-based early warning architecture. So this is SIBR, space-based infrared. It's the follow-on to DSP. It does a great job. Some assumptions that we're working through for this project was that the Iraqi army did not launch their missiles from dense population centers or key infrastructure, despite the more immediate availability of hide spots from those locations. And this is really to protect their personnel, the civilians in the area, as well as just their support infrastructure. You don't want to launch from where your missile supply is. Good chance that they get blown up and then you're not able to complete follow-on missions. So, and then the next three, Scud B TELs had to move quickly to hideaway spots to avoid airstrikes and retaliation. Given that the TELs had low top speeds, they likely did short distance hops. And then the preponderance of shots were made overnight, so they were likely tethered to roads for navigation. These three focus on mobility, which will become key later on for working through the variables in my model. The last one, the strike data accurately represents potential launch locations. This is also a key assumption given the fact that the Gulf War Air Power Survey strike data that I was able to pull is a bit coarse. So, and that leads into the limitations using the imagery and elevation data of the time. So I pulled it from the 1990s, added some significant challenge to the problem set and restricted some variable incorporation. And the coalition strike data presented a small number of points for accuracy assessment overall. So the methodology that I worked with, the foundation of this was the suitability model workflow and the method. Some of you might be familiar with this. What I did was transform this into something more fitting for my project, which is here, the workflow for this. So defining the TEL emplacement, creating base criteria, I broke it down to 3 groups: terrain, physical parameters for the MAS 543 TEL that the Scud B was launched off of, and the tactics. Derived some variables from that, transformed, weighted, and combined, and then located some emplacements locations. So unfortunately, a lot of these variables did fall off, considering that the fidelity of the data that I was using, trying to work off that historical data from the 1990s, just didn't have that fidelity required to plug in everything that I wanted to. So moving into the physical characteristics, this is for the modified Al-Hussein variant of the Scud-B, had a bit more range. And as well as the MOS 543 TEL that it was launched off of. A lot of this, unfortunately, was left behind, like I said, due to that fidelity disparity. So really what was pulled was the maximum gradient, not necessarily the 30% here, as that is a mobility gradient as opposed to an emplacement gradient, in which case I substituted 5 degrees of slope based off of other TELs and systems. So moving into the actual area of operations that I developed. So I went with the southern launch area, as you can see depicted here. And I pulled January 28th, 1991 data. So imagery from the actual war, plugged it in here along with some elevation data to create my area of operations. And what I did was I traced out the main and alternate supply routes, those improved roads, based off the imagery itself to make sure that it is accurate for the time. And then as well as the population centers, Al Basra, Al Zubair, and Qazar are in here as well. So jumping into that assessing accuracy piece, this is that Gulf War Air Power Survey Scud strike locations map. It's very rudimentary, as you can tell. And what I did here is I took this, geo-referenced it into ArcGIS using 33 control points. And as you can see, I have my area of operations kind of highlighted in there. And I took that and made the points a little bit finer on the actual map itself. So one of the key points here is that when you go into ArcGIS and you zoom in, the crosshairs that you see here with the strike locations, it actually gets very pixelated when you zoom in. So what I did was the red dots are the center point of that pixel, and then I drew the buffer out to the edges of that pixel, that very center pixel within the cross. And it's about 2.5 kilometers. So that's kind of the error buffer that I gave for those strike locations. There are 13 here, and then I also later on plugged in 13 random points for comparison of the results at the end. So moving into the actual analysis, I used a couple techniques. It was a bit of trial and error to find the Goldilocks zone as far as what works, what doesn't work, based off of that methodology from before with the variables that did remain. And the first one was map algebra, and I ran this twice, one with one without the buffer roads constraint that you see here, and then one with to some varied results. So for these variables, I had the slope set at 5 degrees for emplacement, aspect with generally south, generally north of those slope faces. Buffered roads, of course, 3 kilometers for mobility constraints based off of the speed, and then just making sure that's remaining relatively close to the roads for the quick shoot and scoop technique that they were employing. And then population centers as the city limits to make sure they're out of there. So moving to the illustration, it kind of demonstrates these variables in action here, I suppose. Keeping away from the population center, 3 kilometers from the road. But what you see is that 0 to 5 degree slope in a general north-south facing direction. So it's either parked kind of uphill or downhill. And this is based off the fact that there was an inertial guidance unit for the Scud missile. So generally speaking, it's going to shoot in the direction that the TEL is going to face. It can't do any fancy maneuvering after that. So, and then here we have the key to the slope piece as far as keeping that aspect north-south rather than east-west, because then you start getting kind of parked sideways on a hill, 5 degrees or greater, you risk a rollover event. Really, once you raise that missile, all that weight's getting pushed up, makes it really easy for it to fall over. And obviously, you don't want that happening. So that's kind of the basis that I ran off of for the variables, and you'll see how it plugs in. So this was the no roads constraint. As you can see, it can go basically anywhere. It's not a very good result. So what this really pointed out to me is that there's got to be some sort of constraining or limiting factor to try to explain these strike locations. And what I went with was that mobility piece from earlier. Very critical role for their tactics and how they employed the system. So I went ahead and added the road constraints of 3 kilometers. And this is what I had for the results there. So about 6 out of the 13 strike locations contained, 5 out of 13 for random points. Still not great, and it really limited everything else in the area of operations. It cut off after 3 kilometers. So I wanted to try another technique using the same kind of variable approach. And I went with empirical Bayes and Krieging or a regression model. And unfortunately, you need about 20 points in order to make that work. And I wanted to use the strike locations. So I only had 13 and it wasn't able to run. So what that led to was the following technique and yielding the best results, the suitability modeler. So and how I worked this, and the key difference here is that I was able to plug in continuous data as opposed to the map algebra's binary kind of coding of 0s and 1s for desirable criteria. I was able to plug in the continuous data. So and then analyze the entire area of operation. So the variables that I was able to go with: slope with a continuous function, weighted 15%, and I used an MS small transformation. And from there, I plugged in aspect again, this time with a range of classes with a weight of 10%, and I weighted valued the generally south directions, southwest to southeast, and then northwest to northeast as higher values. And then I did a cost distance analysis with the roads against slope and plugged that in as a continuous function with a weight of 40%, heavily relying on that mobility as a explanatory variable there. And the transformation that I had was an inverted exponential. And that's what that looks like there. The population centers, I did a Euclidean distance, and then I did a range of classes with a weight of 15%, and I weighted it more heavily, I ranked the values of those classes higher the further it got away from population centers. So making sure that they're keeping their distance from where they're getting their resupplies and so on. And of course, personnel. And then the basic land classification with unique categories weighted at 20%. This was really to cut out the water, cut out the wetlands, so it doesn't get, you're not launching any TELs, you're not launching any Scud missiles from a lake or whatever, or getting it stuck, risking getting it stuck in the wetlands. So this was really to value the open space to make sure that it kind of yields better results there. So the suitability modeler then spat out the suitability map here, and I had 11 out of 13 strike locations contained in the green zone with the suitability value of 8 out of a total of 10. So, and then 7 out of 13 random points in that. I took it one step further and used the locate tool after that to get the 30 best locations based off the suitability map. And within these 5 kilometer radii locations, 7 out of 13 strike locations were contained, and then 3 out of 13 for the random points. So all of this was then condensed down into a table here to compare the results between the strike locations and the random points. And as you can see, the map algebra didn't really have significant differences with those two techniques that I tried, but the suitability map and the locations had about a 30% improvement between the strike locations and the random points. So it's a fairly significant bump in the results there. So really, a lot of this was just finding the Goldilocks zone, testing out the different techniques for the suitability modeler, and finding out that the map algebra without the road constraints yielded some unrealistic results. And then the map algebra with the road constraints proved too constricting, and it omitted any analysis of the suitability past the 3 kilometers from the map roads. And then finally get into that suitability modeler, exploring the entire area of operations, taking advantage of continuous data sets for the variables, and it yielded more favorable results. So overall, the elusive threat remains. The suitability modeler produced a relatively acceptable solution, identifying favorable conditions, as well as the 30 predicted launch points with the 5 kilometer radii, which is a moderate search area for a single pilot, to effectively identify this location with the modeler and then send them out there to do a patrol to try to get ahead of any sort of launches that are going to take place potentially from that area. However, given the low confidence of the strike locations on Scud targets recorded during the Gulf War in that air power survey, the validity of the overall model remains uncertain. It is recommended that further research be continued with modern scenarios and better data sets to support higher fidelity results and increase factors, exploring those variables that perhaps got left along the wayside a little bit more. And with that all said, that concludes my briefing. Are there any questions?
Thanks very much, Alan. Very interesting presentation. Thank you. Does anybody have any questions? I don't know if you can see the chat with your presentation shared, but Ryan does have a question there in the chat.
Yep. All right, I'll stop the share real quick and let's see. Missile strikes or launch locations. So I'm trying to predict launch locations. So where, let's see, we're using known strike locations to test the accuracy. Yes. So I was trying to predict where the tells were going to maneuver to, based off the emplacement criteria, those variables that I was plugging in, that are suitable towards the actual MAS 543 tell, where it would maneuver to, park, and place, essentially, raise the missile and fire. And then I was trying to use the strike locations that were provided by the GWAP survey, to try to test that accuracy, so to speak. So yes, nailed it on the head there. Yeah.
Any other questions? Guess to keep moving it along, Alan, if you're willing to put your email address in the chat, I'm guessing some people might want to follow up with you with some questions.
Sure thing.
Thank you very much. Very interesting. Okay, so moving along, we have Faith Fennick. Faith, whenever you're ready, you can go ahead and start sharing and start your presentation.
Okay, can you see it?
Not yet, but it looks like it's come. There we go. Yep, I can see it.
Hello, my name is Faith Fennick, and my advisor is Dr. Bacasto. My topic was on the impact of road networks on COVID-19 infections in Nigeria. So for my analysis, I focused on Nigeria. They had it seemed like the largest population in Africa. A lot of people were living under poverty. And the city of Lagos has the largest population. This area in Lagos was also where the first COVID case was recorded. The road network system in Nigeria, it is the largest, but it's in horrible quality. Most of these roads were built in 90s and 80s. And they've gotten worse with COVID because people have been socially distanced and not have had the ability to go and work on these road networks. So the goals for this project, the goals for this project were to calculate road connectivity. And then from there, I wanted to see if I could find, or if there was a relationship between areas of high road connectivity clusters and areas of high density of COVID-19 infection clusters. To do this, I used the bivariate LISA analysis. So what motivated me to do this is that there have been uses for transportation networks and shipping networks, and it has influenced COVID-19 a great deal. However, road networks are more recently coming into play with the lower and middle income countries, such as Nigeria. The objective is to determine areas that have high infections, high COVID infection totals per population density, along if there's a high clustering of road network connectivity. My hypothesis is that I think there will be areas of high road network connectivity clusters, along with areas of high COVID-19 infections per density clusters. The data I used for this was the population data from the World Bank, infection totals from the Nigeria Center for Disease Control, and then I obtained road information from OpenStreetMap. So to start off with, most of my analysis and workflow was spent on trying to figure out how to make a line network, even a shapefile of the data I received from OpenStreetMaps. A lot of the roads were mistakes and input error, and some of them were disconnected, and just most of this was figuring out how to create a road network from this. And in the picture, all those red dots are road errors that I had to fix. So to begin with, I started with the pre-processes, which was where I took the raw output from OpenStreetMaps and then converted that into a complete polyline feature that had lines attached and no dangles or no unconnected roads. The first step that I did to achieve this was that I used a buffer and dissolve tool to find the largest polyline. And also, when I did the buffer, I buffered the roads about 20 meters to hopefully get the nearby dangles or unconnected features. Then I also went on to the creation of the trace network, which I started from creating a feature data set in my database. And then I imported the road files, road polylines as a feature class. From there, I went to create trace network, and then I went to enable topology. And first time around, I only generated errors for the topology so that I could fix all the road errors. And most of these road errors were roundabouts, which I had no clue that they were that popular in Africa or in Nigeria, much less in the United States. But a lot of my problems were from roundabouts. I was able to select the normal roundabout or the roundabout features versus the self-intersecting polylines by performing a math formula to figure the circumference and the angle of the circle. And that way I was able to tell if one of my lines was a circle, such as a roundabout, or just a normal self-intersecting line. For that process, for that formula though, I did have to convert my polylines into polygons. So I had an area to calculate for the circle ratio. And then for the other self-intersecting lines, I had maybe about 15. So I was able to go through that manually. And then moving on to the network creation, I started by creating the network data set in my feature data set within the geodatabase. And I was able to then build the network using the validated trace network. And then after that, I had to identify the travel mode and the distance, along with the spatial network file, which did an inverse calculation of each point of the each substate polygon within Nigeria. There are 37 polygons, so 37 substates. And I was able to use the points from inside those polygons to then attach a spatial network file. And then lastly, I used the COVID-19 infection densities to, with the data from the road network spatial file and the bivariate LISA analysis. And then here is a picture of the road connectivity of Nigeria. Right here, that is Lagos, and that is where the first COVID case was recorded. And then these areas are high interconnected areas of road networks. And then moving on to the bivariate p-value in Moran's eye. So with this, I had a very significant value up in the left-hand corner. And then I had not as significant, but still significant values in the bottom right. And then for the Moran's eye, there was an indication that these clusters were more related than they were opposite. And then here's the bivariate LISA analysis. There is one high area, and then up here were the areas of low. So the high was of the high road connectivity, and then high COVID population density, which the COVID population density was the amount of the total number of infections, or the population of each state minus the total COVID populations. And then I divided that by the density of the area. The results indicated that there are areas of high road connectivity clusters with clusters of high COVID-19 infections per population density that are significant. But other reasons for high COVID-19 infections per population density would be wealth, education, and access to water. So going back to this map, this area, from what I've researched, had one of the poorest wealth indexes for Nigeria. And then up here, where there is a low road connectivity along with low population density, low COVID-19 population density, these areas were rural and had less connected roads. They also had better water quality and more access to clean drinking water. And then in the middle, the low highs, a big reason why they also didn't have high COVID-19 population, they had better information systems and notification systems to tell people to not be superstitious of COVID information and vaccines. And then that's all. There are my references.
Okay, great. Thank you, Faith. Does anybody have any questions? While people are typing, I have a question, Faith. It was a really good presentation. Did you did you get a sense that the results you found for Nigeria were similar to what you saw for any other countries that you happened upon when you were reading for doing this project, or I don't know, comparing it to any other similarly populated area?
No, I didn't. I saw similar processes being taking place in Africa, I think Niger maybe, but they had a relationship of road connectivity and population of COVID densities. And I think I might have misread something, but I think in the United States, that has been true, that there are areas of clustering of high COVID population density and high road connectivity. So I think Nigeria was just different. I think because the road network was so large and so they built it up so much, I think that influenced the overall output for that, because yeah, they did have a large road network system, but it was not well maintained. So I think that impacted it.
Yeah, great, thanks. It's the roundabout issue is interesting. It sounds like somebody, a student could do a map of where all of the roundabouts are and what countries have the most and least. It looks like Ryan has a question there.
Okay. So I didn't officially do that, but I did have the backdrop base map, and I looked at the if my roads were around the same area that they should have been or not, but I didn't officially do any ground truthing points.
Okay, well, if you want to go ahead and put your email address in the chat, you might get a couple follow-up questions through email. Okay, so our final presenter today is Katie Paget. Katie, whenever you want to go ahead and share and start when you're ready. And I'll just put a plug in for anybody who doesn't, I'm sure you'll hang out for the rest of Katie's presentation, but in case you get out before I mention this at the end, our next session is for these 596B presentations is Tuesday, May 3rd, and they start at 11. So I hope everybody will be able to come back for that day. And whenever you're ready, Katie, go ahead.
All right, you all can hear me and see my presentation?
Yep, we can.
Okay, awesome. Oh, it's moving. All right, so in collaboration with Dr. Diefenbach, my advisor, we looked at identifying wintering behavior of white-tailed deer in Pennsylvania using GIS. So before I talk about the analysis that we did, I'm going to give a little background on mortality of deer during winter, how they generally go about surviving winter areas, and how white-tailed deer in Pennsylvania act a little differently. So deer generally have a lifespan of about 5 years. Fawn have the lowest survivability rate, and antlered buck come second to that. They usually have a lifespan of about 2 years. And then just like with us, the does tend to last a lot longer, around 5 or 7 years to 7 years. So fawns are at a great risk of starvation, especially in deep snow. In a study that Dr. Diefenbach and a few others did, they actually released 106 collared fawn, and within about 9 weeks, around 70% of them died. And as you can see on this table, natural causes was the leading cause of their death, and that starvation and malnutrition fell under that. So the way that deer usually survive harsh winters is by traveling miles outside of their home areas and going to wintering yards, which are areas generally densely forested coverage using pine and hemlock. And they decrease activity and store fat and generally increase their group sizes from what they have the rest of the year. This helps them avoid severe winter winds and deep snow and gives them more favorable sun and thermal cover than their home areas. It also allows them to move around easier and find more food sources than their home areas would. So in Pennsylvania, the winters are a little less severe and there are shorter periods of deep snow, which fortunately allows for lower mortality rates. There's also a lower instance of conifer cover. So we don't see the deer in Pennsylvania traveling outside their home areas, to wintering areas the way that other deer in cold climates do. And that's why we wanted to take a look to see what type of areas within their home areas that they do tend to prefer. So the objective of this is to identify any landscape and habitat features that those deer in Pennsylvania are more likely to use in winter. And that'll allow us to better understand the behavior of the species and hopefully provide a more accurate way to monitor deer and predict their movement. What we expected to see from the results of the study was a preference for south-facing slopes, which provide warmer and lower snow depths, a preference for high elevation, which along with south-facing slopes provide more sunlight, a preference for clear cuts, which gives them better sources of sun and food, and preference for hemlock and pine habitats, which provide them with thermal cover and less snow. And like I said earlier, deeper snow usually puts the fawns at much greater risk. So to identify the landscape and habitat features that they're most likely to use, we looked at deer activity between January and February of 2019 and 2022. Those are the months with the most snowfall. December has a lot also, but the problem with December is that rut or breeding season tends to go through the middle of the month, and that can cause pretty erratic behavior with deer and how they move. So we left it to January and February. And then we looked at the Susquehannock, I had to practice that word a few times today, state forest in northern Pennsylvania. And I was able to focus on these years and this area because Dr. Diefenbach was able to provide me with GPS color data for 31 white-tailed deer during those time periods and in that area. So that's really priceless data to be able to use. And I was able to acquire the data from MoveBank, which is an animal tracking database. I got DEM data to use for slope, aspect, and elevation use from the Pennsylvania Spatial Data Access. And I acquired habitat and forest GIS layers from the Pennsylvania Department of Conservation and Natural Resources. And I was able to do all of my spatial analysis on ArcGIS. So other than collecting the data, I went ahead and created layers and classifications conducted a spatial analysis, a statistical analysis, and then evaluated the results, which I'll go over now. So here are the rosters that I created from the DEM that I got. And once I had those set up, I went ahead and used the integer function to get true value for every cell and created polygons for each of these layers. For the vegetation layers, I was actually able to get the manual from the DCNR as well, which helped because the layer that they provided had just dozens of fields in it, a lot of really awesome information. So I needed to figure out what was important for us to use. So I focused on the type of vegetation and the size stock. So for the type, it started out having 27 different types of vegetation, including shrubs, different types of maples, all kinds of things. So I generalized that down to 4 different categories. The first one being overstories that have 25% or more conifer cover, and that would include the pine and hemlock that we were expecting the deer to have a preference for. For the sizes, there were 8 categories originally, which provided different diameters at breast height for trees. So, and then whether an area was less or more 50% stocked. So we narrowed that down to whether the DBH was greater or less than 6 inches. So basically, is it a mature area or is it a clear cut area? And again, what we expected to see was a preference for clear cut areas. So process our whitetail deer collar data. It just combines the 2019 and 2020 locations and then selected any winter or any January and February dates and created a layer out of that. Then I had to focus on the study area. So we needed a study area that would provide cells that contained slope, aspect, elevation, and the vegetation. So I used the vegetation as my base layer to clip everything else around. And then from there created a fishnet made up of 30 meter by 30 meter cells. And in order to do the statistical analysis later, I created, or I separated 10,000 randomly chosen cells from that fishnet. And then also did another layer that only contained cells with deer locations during the winter within it. So here's just an example of what those looked like. So on the left are my black cells, which show only deer that were present during winter months. And then on the other side, I have all of my 10,000 randomly chosen cells, whether there were deer present or not. So I exported that information and Dr. Diefenbach helped out with this statistical analysis by developing 9 logistic regression models that looked at the used cells and the available cells. And then for each model, individual deer were treated as a random effect. In all of the models, we looked at slope, aspect, elevation, diameter of the trees, so the size, and then the type of the forest. And then also threw in a few interacting covariants of slope and aspect, tree diameter and aspect, and elevation and aspect. And then once those 9 models were created, used the AIC model or AIC value, the lowest one available, to choose the best fit model. So the coefficients from the best fit model we use to create the RSF that we would use to look at our actual results. So here you can see the equation chosen for the RSF from the best fit model. And I have my attribute table there where I use the calculation provided from the best fit model to run field calculations for each variable and covariate added. And I used those with the equation shown to reach a scaled RSF value for each cell. So any RSF that was 1 is an area that's used on an average basis. If it's 0 or less than 1, then it's less than average. And if it was above 1, it's used more than average. So each of our 30 by 30 cells in the entire study area received one of those RSF values. And this is just showing what our best fit model chose to focus on. So again, we had our slope, aspect, elevation, and tree size. And then we added slope to the power of 2, and then interactions between the aspect and diameter of trees. What we did not include was the vegetation type, because what we found was that less than 1% of the study area had conifer cover that exceeded 25% of overstory. So unfortunately, we weren't able to apply that or get an answer. So our results from the spatial and statistical analysis, we found that they prefer higher altitudes, south-facing slopes, regardless of the elevation, and then slopes that aren't too flat or too steep. So if you look at this grid, you can see that once that the degree of slope exceeded or was under a certain degree, so if it was too flat or too steep, deer actually avoided them. What we found was the perfect spot for them was on slopes of about 20 to 52 degrees. So for this map, you can see a little visual of their preferred 20 to 52 degree south facing slopes in every area within the study area that had that. We found a positive relationship between clear cuts and south facing slopes that's displayed in this graph here, and found that aspect didn't really influence mature stands as much as it did clear cuts. On the map, it's just visualizing all the cells in the area that contain those south facing slopes with clear cuts. So here's our overall result. These are all the cells in the study area with their RSF value. So this gives us the habitat use of white-tailed deer during winter months. And again, 0 being areas that are used less than average, 1 average, and anything over 1 are areas that they prefer to use more than average. And here we're just showing those major relationships of slope and south facing slope, or slope degrees and south facing slopes, and then clear cuts and south facing slopes compared to our final RSF results. So you can have a visual of that. So in conclusion, the best place to find deer during winter is in clear cuts on 20 to 52 degree south facing slopes. South facing slopes provide access to sunlight and food sources and make it easier to travel and avoid predators. We found when protected from cold and snow, by those south-facing slopes, deer will choose clear cuts for better opportunities to forage seedlings, travel, and bed down. My hope is that this type of information can provide wildlife and management organizations with more meaningful monitoring and population control of white-tailed deer, and could aid in determining regulations and tag limits for zones with different habitat types. Could also help with determining boundaries for protected areas year to year, especially for fawn, if they're in an area where population strengthening needs to be prioritized. For land management, the information could be used for clear cut and reforestation decisions, especially with clear cuts on south facing slopes that might be facing greater browsing and less tree regeneration because of the deer eating the clear cuts. This type of analysis can also be used towards other impacting variables on white-tailed deer, such as predators' biological factors, such as waste disease, or what kind of group sizes are involved. Some of that is very hard data to come by, of course. And of course, this type of analysis can also be used towards deer in other areas that don't have as much research done on them, or other keystone species or conservation efforts or hunting efforts. Here are my references. Does anyone have any questions?
Thanks, Katie. Great job. Does anybody have any questions?
All right. So Ryan said, since deer seem to like relatively steep areas, which would be less desirable for most human uses, does your study suggest that human activity doesn't have a great impact on deer mortality? So vehicle strikes aside. I would not say so. I would assume in a lot of areas, vehicle strikes do have a pretty high impact on their mortality. We were really lucky to be able to use this study area because it is mostly park and forest. So even though there are roads, it wasn't a huge factor. So going back to, let me see if I can bring it up again. Going back to the research with just the fawns. So this is a very specific study with just fawns over 2 years. But vehicles were a big impactor there. So behind natural causes and predation, vehicles was the third leading cause of the death just for those fawns. And I'm sure most of us have seen, especially in Pennsylvania, it's usually the big ones that you get. So I think that would just be a different study, maybe in a different type of area.
In case anybody's typing one last minute question, I know I mentioned this when you presented your proposal in 596A, but I really love seeing the results of this because, like I had mentioned before, I am in the Penns Valley area, one of the areas where this was done. And so it's really interesting, you know, apart from just seeing the vehicles going up and down the road and trying to find those collared deer or whatever, it's really interesting to see the actual data behind that. So yeah, great job. Any other questions? If you could just put your email address there in the chat, Katie, there might be some people who want to follow up with you.
Sure.
Great.
I've only visited Pennsylvania a few times.
Yeah.
like different areas like the Allentown area, and
Okay.
I couldn't believe how many deer there were.
Yeah,
It's wild.
yeah, and it must have been funny to do this study and just kind of have to picture everything.
Yeah,
And,
I grew up in the South, and I've hunted deer through Florida, South Carolina, and Georgia my whole life. I've only seen one collared deer the whole time I've ever been hunting.
oh, wow.
But yeah, obviously this is a very different breed.
Right,
You guys are dealing with.
well, good. Very good. Well, thank you, everybody, for coming and watching the presentations. Thanks to the presenters. And again, congratulations for being almost done. I hope you will all, like I mentioned before, continue to come to the remaining presentations. I'm sure everybody who still has to present would appreciate your attendance and questions. So maybe I'll see you in a future session there. But everybody, I hope you have a great day. Thank you.